situation. Let's have my favorite one, which is calcium hydroxide again. But now let's react with phosphoric acid. And again, I'm ignoring the states. I'm just focusing on balancing. Goes to Ca3PO4 2 plus H2O. Okay, so do you guys want me to write the elements underneath? Do you like see that? Calcium underneath is the metal. There's no other metals. So I have 1 and 3. So what am I going to do? So I would say put a 3 in front of that calcium. So now they're both 3. You have to do that when you have to cross it out and go like that. It helps actually. Okay, then let's look. So what I'm going to do, what's the non-metal that's not hydrogen and oxygen here? I see PO4. And PO4, if you look at it, PO4 doesn't change. It doesn't go to PO2 or P or anything like that. So actually, I can just count PO4. Is that all right? I hope this is okay. So how many PO4s are on the reactant side? I count 1, yeah. Someone said 1. How many on the product side?
2.
2, good. So to fix it, I'm going to put a 2 out in front of this. See, you got to do that, yeah, like that. And then cross this out. Now I have 2 phosphates on each side. So now I'm going to go to hydrogen. All right. How many hydrogens are on the product side?
2.
2. How many hydrogens are on the reactant side?
6.
Careful. Okay, wait, let's ignore calcium hydroxide. How many hydrogens are here? Okay.
3.
Well, but there's a 2 in front. So the 2 multiplies by everything. So there's actually 6 there. How many hydrogens are over here?
2.
Well, but there's 3 in front.
6.
So I have 6 hydrogens here and 6 hydrogens here. So actually 12. Someone got that. I saw it too. But okay, good job for that person. So how do I fix it? What am I going to do? I want to get 12. So this is kind of the idea of the lowest common multiple. The lowest common multiple between 2 and 12 is 12. So I want to have 12 on both sides. How do I get 12? Well, someone said add 6. I'd actually, technically, we're multiplying by 6, or put a 6 in front. Yeah, 6 times 2. There we are. So that's now 12. Now let's check the oxygens. This might be tough. Okay, let me put this up so you can see the oxygen. So if I'm doing oxygen, can we ignore PO4? Because I've already counted the oxygens in that. Do you mind if I do that? We could count all the oxygens if you want. But since PO4 stays unchanged. Okay.
So how do you just randomly add 6? I'm confused on that. You just
here
can do that?
Yeah, because I mean, technically, up here, there were 2 hydrogens. 6 times 2 equals 12. I wanted 12, right? So I want to put a multiplier that gives me the same number of hydrogens as this. Yeah?
Okay.
Okay. Perfect. All right. So if you guys don't mind, can I ignore the oxygen in PO4? I'm going to ignore these oxygens because they've already been counted. They're the same on both sides, yeah? We could count them. How many oxygens are here?
1.
6.
6, good. Because there's 2 OHs and then there's 3 calcium hydroxides, yeah? All right, so I have 6 oxygens over here. Not counting the phosphate, how many oxygens are over here?
6.
6.
So this is actually balanced. Technically, if I wanted to count the total, it would be 6 plus 2 times 4, 8, which would be, technically there's 14 oxygens on both sides, but we didn't have to do that. right? Because those other 8 were already in phosphate, and phosphate was already counted. So you can do that if you want. You could do 14 and 14, or you could do 6 and 6 and ignore the ones in phosphate. You could do it either way. Okay, let's continue on. Okay, I'm going to do an even harder one. Are you guys ready? Okay, so I want to do a combustion reaction. These are very important. C2H6 plus oxygen goes to carbon dioxide and water. Super important reaction. Okay, so balance the metals. Where are the metals in this? Are there any metals?
No.
No metals. Okay, so go to non-metals that are not hydrogen and oxygen. That's only what?
Carbon.
Carbon. So on the left side, I have 2. On the right side, I have 1. So what am I going to do? I want to have 2. So I'm going to put a 2. 2 times 1 is 2. The lowest common multiple between 2 and 1 is 2. Right? Okay, so that's now 2. Okay, let's look at hydrogen then. Hydrogen, here I have 6. And over here I have
2.
2. How will I fix that? Lowest common multiple between 2 and 6 is 6. So I want 6 over here. How will I get 6?
Multiply by 3.
Multiply by 3. Okay. Now I have 6. Let's go to oxygen. So on the left side, I have 2. Oh, is that me? On the right side, how many oxygens are on the right side?
3.
Not 3 and not 1. Careful. Okay, so how many, wait, let's slow down. How many oxygens are in this term?
7. You have
3.
3, because it's
10?
3 times 1. How many oxygens are in this term?
4.
4.
So actually I have
7.
7. What? Okay, so this is where we really have to think hard. Both of these, they're both prime numbers. So actually the lowest common multiple is actually the product, is 14. So there's 2 ways to do this. I could do what we call pseudo balancing. People don't like that so much. I don't know. I guess students are doing. I could show you both ways if you want, but I actually like the lowest common multiple. So if I have 2 here and I want 14, how would I get 14 of these over here? Someone said multiply by 7. That's absolutely correct. So now I have 14 there. Okay, here's the trick. If I have 7 total here, how will I get 14?
Multiply by 2.
Yeah. So I'm gonna double this. Times 2 for everything. Everything product. So that's actually, I'm going to rewrite the whole darn thing. Is that okay? So I'm going to write C2H6 plus 7O2 goes to, okay, I'm going to double that, which would be how many?
4.
4 CO2. And I'm going to double that, which would be how many?
Plus 6.
By
H2O.
6. H2O. Okay. And then what did we do? Okay, so wait, now I fixed the oxygen, right? I have, where did I go? I have 6 plus, how many are there?
8.
6
6.
plus, yeah, 6 plus 8. So let's go back, let's check the oxygen first. 6 plus 8 is 14. And now over here I have 7 times 2 is 14. So oxygen's okay. Let's go back. What about carbon? Did I fix it? Let's see. How many carbons? Over here I have 2. Over here I have 4. So when I doubled stuff, I need to go back and fix this one. How will I fix this one? What will I do?
Add a 2.
I'm going to put a 2. Now that's 4. And let's check the hydrogens. How many hydrogens do I have here?
12.
12. How many do I have here?
12.
Okay, and I haven't actually changed the oxygen, so it should still be 14. So that's balancing a combustion problem. I could give you another one of those if you want to try another one. Do you guys want to try another one, or we can move on? What would you prefer?
Could we do one more?
Okay, let's do one more, certainly. C4H10 plus oxygen goes to carbon dioxide and water. Let me hide that other one. Okay. And carbon, 4 and 1. So I'm going to put a 4. Yeah?
Mm-hmm.
Hydrogen, 10 and 2. So I'll put, what will I put? How will I get rid of the 2?
Multiply by 5.
Yeah. Okay, so now hydrogen's 10. Oxygen, how many oxygens are here?
2.
2. How many are in this term?
8.
8 and
9 or 5.
8 and 5 is 13. Oh my goodness. So what's the lowest common multiple of 2 and 13? They're both prime numbers. So actually, the lowest common multiple is 26.
26.
Oh my goodness. How do we get 26? What am I going to do?
Do you multiply them by each other, like 13 by 2?
Yeah, so I'm going to want to,
Multiple.
I'm going to go 13 times 2 is 26 there. How do I, if I have 13 here, here's that thing. If I have 13 here and I want 26, what have I got to do?
Multiply by 2.
Yeah, I'm going to double. So I'm going to double times 2, right? Okay, so I'm going to have, let's put it in
26 on both sides.
I want 26, so I have 13 oxygens here. I doubled 4, so I'm going to have 8 CO2. And I doubled 5, I'm going to have 10
H2O.
water. And then if you notice, I've changed the number of carbons here to 8. So let's go back, and if I want to have 8 of those, it'll be 2C4H10. Do you guys want to learn the second method?
Is it easier?
Some people like it, some people don't.
Sure.
What I don't like about it is some people don't finish it. They get halfway done and then they quit. It's called pseudo balancing. So I'm going to do it with this same example. Okay. So here we have C4H10 plus oxygen goes to CO2 plus H2O. And so what we did is we said, okay, 4 and 5. That's what we did before, right? And then the oxygen was 13 and 2, right? And so what I'm going to do is I'm going to make this one to have 13 oxygens. That would equal, well, 14 oxygens would be 7 O2s, right? You agree with that? 7 O2 would equal 14, and 6 O2 would equal 12. So what I'm going to have...
But how would you know that it's going to be 13?
Well, because you have 13 oxygens over here.
Oh, okay.
So if I want to have 13 over here, instead of doubling stuff, I could just make 13 by having 6.5. And that's what's called pseudo-balanced. So to do pseudo-balance, first thing is pseudo-balance.
But in the videos, it says that you can not have like half of molecule.
No, yeah, you cannot have half of a molecule. So there's a second step, is double everything. You are absolutely correct. Double everything. So I still am stuck rewriting this entire equation. I'm just going to multiply everything by 2. So 1 times 2 is 2 C4H10. Let me bring that up a little higher. And what's 2 times 6.5?
13.
1302 goes to 2 times 4, 8 CO2 plus, and then 2 times 5, 10 H2O. Okay, and so we at the end of the day, we get the same answer, right? I want to, before I leave, I'm going to leave balancing really quickly here, but there's one other thing I wanted to talk about is if you have a common denominator. So we talked about lowest common multiple. If you have a common denominator, then you're what's called, you are your, quote, overbalanced. And that's not correct either, to be overbalanced. And if that's the case, you need to divide out the common factor. So let me just do a really simple one. Let's go back to water. What if after balancing my water, I had 4H2 plus 2O2 goes to 4H2O. And so I might notice, you guys see a common denominator there? What's my common denominator?
2.
Yeah, common 2. So then that means I'm going to divide everything by 2. I don't want to leave it like this, even though if I look at it, I have 8 hydrogens here and I have 8 hydrogens there, and I have 4 oxygens here and 4 oxygens there. But the chemists don't like it because actually the balanced chemical equation is always the lowest common multiple. And so if you have a common multiple, then you have to divide it out. So I just divide this by 2 and just fix it back to 2H2 plus O2 goes to 2H2O. Now there's no common. Does that make sense? Okay. So that is balancing.